So today I'm going to talk about how to integrate trig functions, and I have summarized two rules that will be extremely helpful for you to do so. So let's get to it. Rule number 1. In general, you can integrate a product of the form sine to the power of mx times cos to the power of nx if either m or n is an odd positive integer. So if m is odd, we change all but one sine into cosines, using sine square x is equal to 1 minus cos square x. And if n is odd, we change all but one cosine into sines, using cos square x is equal to 1 minus sine square x. So we basically have to change an odd power term. So let me show you what I mean by that. So the integral of sine square x times cos to the power of 5x dx, we can clearly see that cos x is the term that is to the odd power. So we must change cos to the power of 5x into cos x times cos to the power of 4x. And for cos to the power of 4x, we need to write it as bracket 1 minus sine square x bracket squared. So moving on to rule number 2. In general, we can integrate sine to the power of mx or cos to the power of nx, or sine to the power of mx times cos to the power of nx if both m and n are even, by using the following trigonometric identities. So sine square x is equal to 1 minus cos 2x over 2, or cos square x is equal to 1 plus cos 2x over 2. As an extension to sine to the power of mx times cos to the power of nx, as long as m and n have the same power, we can also use sine double angle identity. I'll also go over an example of that. So let's jump to our first example question. In this question, I'll be using rule number 1. So we're trying to find the integral of cos cube x times sine to the power of 4x dx. And we can see cos x is a term that is to the odd power, so we must change that into cos x times 1 minus sine square x. And I need to use u sub now. So what am I gonna set as u? So for u, if it's like an even term multiplied by an odd term for this trig case, we must always set u as the odd term. So in this case, the odd term is sine x, and I have du is equal to cos x dx. The reason why I wish to do that is because this way I can get everything in terms of u and have du instead of dx. So now I expand that out, and I can just use formula to do easy integration. However, I'm not done right there. I need to change my answer back to x because the question was originally in x, so you must answer in x. Never leave your answer in u if the question didn't start with it. So that's good for this question. Moving on. Example number 2. In this question, we'll be using rule number 2. So we have the integral of cos square x dx, and we can straight up just sub in the formula. So we know that cos 2x is equal to 2 cos square x minus 1. So cos square x is equal to cos 2x plus 1 over 2. This is an equation that you need to be familiar with. This way it'll make calculations easier as you don't have to derive from the formula every time. So now subbing that in, we can straight up do integration by using the formula as cos integral of cos 2x is equal to sine 2x over 2. And don't forget to plus c. So moving on to example number 3. For this one, we'll be using the extension of rule number 2. So first seeing this question, you must expand it first. Because when you expand it, you see that you have sine square x plus cos square x, which immediately should ring a bell that it is 1. And you also have 2 sine x times cos x, and you should be familiar with your trig identities, as that is immediately sine 2x. So we can straight up do integration from here. And sorry, there's a dx over here. So we have x minus cos 2x over 2 plus c. So moving on. Example number 4. So this is probably the most challenging question out of all the examples I'm giving you guys. So this will be an extension of rule number 2 that I said that I will go over. This is integral of sine square x times cos square x dx. Now you must be thinking I can sub in individually sine square x and cos square x. However, that way you'll have to multiply cos 2x with cos 2x, and you also need to do a bit of algebra when expanding it in the first place, right? And then you need to use the formula again, so you basically need to sub it in 3 times. Now, if you use sine 2x, it will make your life a lot easier, as the algebra is also easier and you don't have to sub in that many times. It's just more straightforward. So now we can see that it is really close to sine double angle identity, as sine 2x is equal to 2 sine x cos x. So if we have sine square x times cos square x, that is sine squared 2x over 4 dx. So now we see that this is squared, so I must sub it back into the sine square x is equal to 1 minus cos 2x over 2 formula. So subbing that back in, I have everything in the power of 1, so that is perfect. And now I can just apply the formula to do easy integration, and we can easily get the answer. This is not the only method to do this question, but I do believe it is one of the easier methods to do so. So I hope that was helpful. Thanks for watching.